We are still looking at variation. We've looked at direct variation. Today we're adding inverse variation. The things we did before were situations where two variables were directly proportional to each other, such as in the case of adding liters of water to a bucket and the depth of the water rising. So as we add more liters, the depth of the water goes up. In this case, it was linearly. If the bucket is not straight, then it's going to not be nonlinear. But still, this was direct proportion because as the liters go up, the centimeters of depth also go up. So as the one variable goes up, the other one goes up as well. That is both direct variation, whether it's linear or nonlinear. As one variable goes up, the other one goes up as well, which makes it direct. So what is inverse? Imagine a fence, and this guy is going to paint it. This will, for the whole fence, this will take him a certain amount of time. Let's say it takes him 3 hours. Let me just write that in a nice little table. Number of guys. This is one guy, right? How many hours does it take him to paint this whole fence? Let's say that's 3 hours. Bad choice. Let's say it takes him 30 hours. Okay. This is a situation where as the number of guys painting goes up, like if this other guy shows up and helps him out with the painting, the time it takes him to paint it, the whole fence, is going to go down. That is inverse proportion. These two variables vary inversely. The more guys painting, the less time it takes them. Imagine there's two guys. Because it takes one guy 30 hours, if we double the number of guys painting, the number of painters, that's going to take half the time that it would have taken. What if there's 3 guys painting? That would divide the original time by 3, which is 10 hours. Now, if we were to plot this on a graph, say this is the number of painters, and this is the hours of painting. I'm going to just do it very roughly. That'll be 30, this will be 15, 10, 5, 25, 20. One guy, 2 guys, 3 guys. One guy takes 30 hours, 2 guys, 15 hours, 3 guys, 10 hours, and you would get a graph looking like this. As the number of painters increases, the number of hours decrease. Pretty cool. That is called inverse proportion. And y is the number of hours, x is the number of painters. Y in this case is inversely proportional to x, which is I should say 1 here. Y is inversely proportional to x, and so forget this. So in an equation, that would look like this. Y is always equal to some constant, the constant of proportionality, divided by the x value. In the case of these painting men, y, the number of hours, let's plug in one person, 30 hours. So y is 30, is equal to the constant of proportionality divided by x. X is the number of guys, which is 1. Solving for x, for k equals 30, obviously. So now we have our equation, and I'm just working up and down. Sorry. This is the equation that describes this relationship. We can plug in any number of painters for x to find how long it would take them. Or we could plug in a number of hours that we have and calculate how many painters we would need to be done in that time. So, pretty cool. I think this is the only example I'm going to do. I think this is enough. So remember this. Y is indirectly proportional to x, if inversely proportional to x, and this is what a formula for y in terms of x would look like. All right.